Alright, so yesterday's homework in the Ready, Set, Go had a question very similar to this. It says the average test score in Martina's math class was 81 with a standard deviation of 4. If she scored 2 standard deviations above the average, which score did she get? So this is where we're going to start to combine the actual numbers for the average or the mean along with the standard deviations. Whenever you collect data, you're going to have an average, and then if it's normal, you'll have those standard deviations that tell you how closely clumped the data is. And so the easiest way to visualize this is we're just going to make a simple number line. Okay? And on this number line, let me switch my paper here. We're going to look at the middle. And the exact middle of this number line is going to be, we'll say right there. This here is our mean. The mean is always in the middle, as we talked about with our normal distribution. So that's where that high peak is. And so that mean is going to be there. And we're going to start using the symbol that looks like a little cursive M. That is mean. Okay? So the mean for her class was given right here. It said an average score of 81. So her mean for this class is 81. Then we're going to take a look at the standard deviations to kind of see the spread or how this normal distribution works. And to do so, we're going to make 3 tick marks equally spaced to the right and 3 tick marks equally spaced to the left. Now what this is signifying is that some people do better than 81 and some people do worse than 81 in the class. But the average or most people are in that 81 range, very close to it. So when we look at this, we need to know what our standard deviation is. And in this case, we said that the standard deviation was 4. And let me just make sure. So we say here, this is our average that we're looking at. So if the standard deviation is 4 points on this test, we're going to say that this point here is 85. You can see we added plus 4. Then we're going to go plus 4 again. And then we're going to go plus 4 again. Okay? And we're going to talk about what these standard deviations mean in a little bit. For now, we're just trying to make our grid so we can actually use this in the real world. Well, the same thing goes for the other way. If that way is going up, then this way is going to go down. So this becomes a score of 77, 73, and then down here we have 69. So what we end up having is this distribution of scores. And so we take a look at it as this. We can get rid of these. These are just to help us count through there. But we have this number line here. And this number line is showing us the mean, which is in the middle, and then our standard deviations. And so what we're going to do is we're going to say that this here is plus 1 standard deviation. And we're going to start using this symbol for standard deviation. Okay, it looks like a little O with a curly Q on the top. So again, this is mean, this is standard deviation. And we're going to be using those symbols a lot. So this is plus 1 standard deviation. This is plus 2 standard deviations. And this is 3 standard deviations. Down here, we're subtracting 1 standard deviation, 2 standard deviations, and finally 3 standard deviations. And this is going to give us our curve, because eventually we're going to be looking at our normal distribution curves again. And you can see it kind of fits right in there. And we're going to talk about what that curve means and why these numbers are so important. But this is just for us to set up. So let's get back to the question here. It says, if she scored 2 standard deviations above the average, what score did she get? Well, if this is the average, and we go 1, 2, then her score would have been is 89, because we went 2 standard deviations above. And again, you can go below, you can go above. It doesn't really matter, but what's happening here is we're trying to figure out what the mean is and then what these tick marks are going to be. And we always do 3 to the left and always do 3 to the right that are equally spaced. We don't do any less, we don't do any more, because in a second you're going to see why we choose those 3 and why it's so important. So then you might be asking yourself, why is this even relevant? Why couldn't I just say she got an 89 and did better than the class? Well, sometimes we want to know exactly the percentage of how we do. Okay, so for instance, we want to say, is her 89 really that rare? Is it really that good? And you see this a lot with SAT and ACTs. They'll say you're in the top 22 percentile or the top 15 percentile or the lower 38 percentile. They give you all these percentages, and that all comes from a normal distribution curve. And so what we're going to be doing is we're going to be using this curve in order to figure out percentages. And we're just going to be doing simple percentages down the road. But that's where this comes from, is these percentiles are big parts of normal distribution, and being able to set it up like this allows us to see where we fall and how much better we did on something than we did on something else. So this was Martina's math class that we're looking at, and so we were just making sure we knew the average, the standard deviation, and how to build that graph. Then we're going to start using this to evaluate certain things like, was she better in this class or in another class? Because the math and the science scores don't necessarily mean the same thing, but we can see which one she did better in by looking at how much further along she is to the right or to the left of that average in each class. So here's how we're going to do this. We're going to say, what percentage is her score compared to the rest of the class? So we're trying to figure out how good is that 89 that Martina got in her class, in her math class. Is it really good? Is it okay? I mean, it's only 8 points above the mean, so it can't mean that much. Or is 8 points a lot? We're not entirely sure at this point. This is where we're going to start looking at this normal distribution a little bit differently. And so if we go ahead, I'm going to draw just a generic one here. Okay, so we're going to have our mean in the middle. There's that mean symbol. Then I'm going to go 1, 2, 3 to the left. 1, 2, 3 to the right. This is minus 3 standard deviations, minus 2 standard deviations, minus 1 standard deviation, plus 1, plus 2, plus 3. And we're not even worried about numbers at this point. We just want to kind of look at this normal distribution curve and try and understand what's going on. We're going to bring Martina's numbers back into it in just a little bit. But for now, we're just using the general sense with variables and things that are unknown. So again, this curve goes up and then it goes down, just like that. Kind of a crude drawing, but it'll work. And so what we're going to be looking at is, why do we care about these standard deviations? Why do we care about these little sections? Well, these sections are really important to us because basically what we're saying is that everything under this curve represents every possible outcome of what we're trying to study. Okay, so what that means is that underneath the curve represents everybody. So that is 100% of everything that we could test for. And that is under the curve here. So if we look at this, this whole curve shows every possible outcome from whatever we're studying. So in Martina's case, it shows everybody's possible scores. And notice that the curve doesn't actually stop after 3 because there is a chance that something could happen. It's not impossible but it's very unlikely is what we're going to be starting to say here. So this here is 100% of everybody. Okay, that's every single person that's possible outcome. So you can start to maybe see, well, we want to try and look at what each section's going to be worth. And by doing that, we have our standard deviations. So if we go out to 3 standard deviations, so let's say if I went from this here to this here in red. Okay, so if I'm looking at this red section, somebody did a lot of calculus back in the day and started to figure out how to understand how much data is under this curve. And we say here that this represents 3 standard deviations, so plus or minus 3 standard deviations, so going plus 3 to negative 3 represents 99.7% of all the data that we could collect. So that means there's 99.7% chance that you're going to fall between 3 and negative 3 standard deviations from the mean. So there's also 2 standard deviations. So if we look here, we could also say, well, what about 2? Well, 2 standard deviations is a little bit smaller than 99.7. You can see that here. But it's not entirely too small. In fact, when we look at these here, let me move this so it's still pointing in the red. Oops. Good enough. Okay, when we look at this here, what we're looking at now is 2 standard deviations. So we could say plus or minus 2 standard deviations. And that is actually 95% of all the data. So it's a little bit less than the 100. It's a little bit less than the 99.7. But it's still a good chunk. About 95% of all people or everything we're studying will fall in between 2 standard deviations. And the last one we'll do here in purple is our 1 standard deviation. And in between those, this purple section the purple section is plus or minus 1 standard deviation. So we're going 1 standard deviation above and below, and that is actually going to be 68% of all of our data. So if you're in that purple section, that's the chunk that really matters. Kind of what we're saying here is that that's the general average, is that you're going to be close to the mean, but the majority of our data, 68%, is right there in that purple chunk. As we go out to 2 standard deviations, it gets to be a little bit more, and then 3 is a little bit more, and then obviously 100 is the most you could possibly have. And those are those little outskirts there. And so what we call this here is we call this our 68, 95, 99.7 rule. And all that's simply saying is that between 1 standard deviation, you get 68%. 2 standard deviations, 95. 3 standard deviations gives you 99.7 of all the data. So it's very helpful to understand these and have this in your notes, because when we're going to look at these things for our homework or tests or assessments that come up, your 68, 95, 99.7 rule is really good because it tells you each one of those chunks that's under the curve, and you can start to figure out where they fall and how they do it. Okay? And again, this here, like we said yesterday, this is our 50% line. Above and below the middle is 50% of our data. So we're going to start looking at this 68, 95, 99.7 rule and break it down just a little bit more. So feel free to pause to get down the notes now And then we're going to take a look at what about smaller sections, because we still have some other ones here that aren't as big. And so what that's going to look like, let me draw my curve again real quick. Put the mean, 1 standard deviation, 2, 3. All right, so I have my mean here. I've got my standard deviations next to it. So we're actually going to start taking a look here at these individually. So what is each slice going to give us? So if we look here, we said that our graph has 68% between here and here. So that makes up 68%. If I split that in half, that means each one of these sections is going to be worth 34%. Because together, that makes up 68. So then we have to figure out, okay, well there's 68 there, but there's 95 between here and here. So how do I figure out what's left over? Well, if I do 95 minus 68, I'm going to get 17. And then 17 divided by 2, or sorry, 27. 27 divided by 2 is 13.5%. And lastly, the difference between 95 and 99.7 is 4.7, so that divided by 2 is here, 2.35%. And then what's left over out here is a very small chance. We're actually going to only have a 0.015% chance of that happening. Or sorry, 0.15. And out here is 0.15% as well. So it's really important to have both these graphs in your notes, because they're going to allow us to then take a look at and say, okay, what percentage did she do? How many people are worse or better than her in terms of getting this this stuff in relation to how her score looks in the class. So let's take a look here and see where she was. We said she was 2 standard deviations above the mean. So Martina was 2 standard deviations above the mean. So she's going to be right here. So we went 1, 2. So if she's right there, then what percentage of people did she do better than in the class? Well, everybody else that scored below her is from here to here. So if we add up all their scores, or all the percentages, we can figure out what percentiles she did. And so if we add all those up on our calculator, we end up coming out with 97.5%. So she did better than 97.5% of all people in the class. She was in the top 2.5%. So she did really, really good. Okay, so this is what percentage she was at. So the further you get from the mean, you can see that it becomes harder and harder. There's not a lot of room there, as we see up here. There's not a lot of people in these far areas because the area is so small. And so we want to be able to figure out exactly what that could be by using these rules here. And so feel free, like I said, at any time, make sure you pause if you need to get these numbers down, if you need to draw a sketch, in order to see what's going on here. Because these are what the types of questions we're going to be dealing with today are, and trying to figure out what percentage people did below or above, or how many times did people score higher than a 92, or a 77. How many people scored below a 77 in terms of percentages? And we can start to use these number lines and curves to figure that out. And so we're going to do a little bit of practice now on this, and then we're going to come back and try and finish it up and kind of make sure we got all this stuff down.